Hey there, and welcome to your pre-flight explainer briefing. Let's just jump right into it. I'm stepping in as your Microsoft Azure SQL database expert and mentor today, and my absolute top priority is getting you completely prepped and ready for your upcoming hands-on lab. We're going to break down the exact performance tuning concepts you'll be facing. That way, by the time you actually put your hands on the keyboard, you're going to know exactly what to do.
So, let's establish the stakes right out of the gate. Here is the literal mission statement you're going to see in your lab. You've been hired as a senior database administrator to help with performance issues currently happening when users query the AdventureWorks 2017 database. You're not just mindlessly running scripts today. You are stepping into the shoes of a lead DBA to rescue a struggling system. Your job? Find the bottlenecks and systematically wipe them out.
Okay, here's our flight plan for this overview. 1. The performance mission. 2. Decoding query execution plans. 3. Unlocking the query store. 4. Mastering query hints. And 5. Making sure you are ready for hands-on labs.
All right, Section 1, the performance mission, your tools for the lab. Because, before you can tune anything, you gotta have your workbench set up. During those crucial first few minutes of your lab, you're gonna be entirely focused on staging your environment. You'll fire up a Visual Studio Code session and use a git clone command to pull down the Microsoft Learning repository directly into your local C/lab files folder. Once you've got those files local, you'll jump into SQL Server Management Studio, or SSMS as we usually call it, connect to your default instance, and run a T-SQL script to restore the AdventureWorks 2017 database from a backup file. Think of this as unpacking your toolbox. Once you get that beautiful database restored successfully message, well, that's when the real fun begins.
And that brings us to Section 2, decoding query execution plans, looking under the hood. If you're going to fix a slow query, you really need an X-ray machine to see how the system is actually thinking.
That X-ray machine is the execution plan. Essentially, it's a map showing exactly how the SQL Server Query Optimizer has decided to go out and fetch the records you ask for. In the lab, you'll start this diagnostic process by enabling a setting called Show Plan All. What this does is generate a text-based version of the execution plan right in your results pane without actually having to run the full query output. It's super handy. It lets you see if the optimizer is doing something super efficient, like an index seek, or if it's doing something just horribly wasteful.
And speaking of wasteful, it's time to meet the first major villain you're going to face in this lab, the Key Lookup. When you run your first suboptimal query and check that execution plan, you're going to see a Key Lookup operator. Now, what's totally critical to understand here is why this is such a bad thing. A key lookup happens when an index doesn't contain all the columns your query actually asked for. So, SQL Server finds the row in the index, but then it has to take this incredibly expensive detour all the way back to the main table just to grab those missing columns. And here's the kicker. It has to do this detour for every single row it retrieves. It is a massive, massive performance drain.
So how do we take this villain out? Well, in the lab, you'll notice a new T-SQL script that literally drops the inefficient index and recreates a better one. We add the modified date to the primary index keys, and this is the crucial part. We add an include clause for carrier tracking number, order quantity, and unit price. By literally including the exact output list columns that the query needs right inside the index itself, we create what's known as a covering index. When you run that query again in the lab, you're going to see that key lookup completely vanish. The X-ray comes back totally clean.
Okay, let's pivot to our next tool, Section 3, unlocking the query store to detect regression. Because sometimes, queries that have been running perfectly fine suddenly hit a brick wall.
In this next phase of the lab, you're actually going to simulate a database regression. You'll run a script that drops the database compatibility level down to 100. This is basically a time machine, forcing your modern database to act like it's running on SQL Server 2008. You'll generate a random workload to simulate a bunch of user traffic, and then, bam, you'll fast forward the database back to compatibility level 160, which is SQL Server 2022, and run the workload all over again. What this does is create a beautifully messy scenario where entirely different execution plans are actively fighting each other in the system's memory.
To untangle all that chaos, you're going to open up the top resource-consuming queries report inside SSMS. This right here is where the magic of the query store really shines. You'll configure the report filter to specifically look for queries that have a minimum of 2 query plans. This brilliantly isolates the exact queries that change their behavior during our little time travel experiment. You're basically hunting for a massive spike in duration on the bar chart.
When you finally click on that top consuming query, the query store is going to reveal two drastically different execution plans for the exact same request. One of them ran super fast, the other painfully slow. But here's the cool part. As the DBA, you don't just have to sit there and accept the slow one. You will physically select the plan ID that shows the much lower duration on the y-axis, and you'll hit the Force Plan button. You'll see a little check mark appear. Boom. You've just manually overridden the SQL optimizer and forced it to use the optimal path.
Which brings us to our final optimization technique. Section 4, Mastering Query Hints. Because sometimes the optimizer makes a terrible choice, not because the index is bad, but because of the parameters we're feeding it.
In the final stretch of your lab, you're going to run two identical queries. The absolute only difference. One is searching for salesperson ID 288, and the other is searching for salesperson ID 277. Yet somehow, they produce totally different execution plans. One does a lightning-fast index seek, the other does a slow, grinding, clustered index scan. So why on earth does this happen? Well, it's because when you hard-code a constant value into a where clause, the optimizer looks at the exact statistics for that specific number and treats them as two completely unique queries.
Naturally, as a smart developer, you might try to fix this hard-coding issue by just using a local variable, like @salespersonID. But here is the trap. If you use a variable, the optimizer has to compile the execution plan before the variable is actually assigned a value at runtime. So it's essentially flying blind. It has no idea if that variable is going to return one single row or a million rows. So it defaults to the absolute safest but usually slowest method, a clustered index scan. Yep, the very thing you did to make your code cleaner just totally tanked your performance. It's called parameter sniffing, and it's a huge headache.
So how do we guide our blind optimizer out of the dark? The fix is actually incredibly elegant. We keep the variable, but at the very end of the query, we tack on a query hint option recompile. This one simple little line tells the SQL query compiler, hey, wait, do not build a plan yet. Replace this variable with its actual runtime value first and then compile the best possible plan.
And that data proves exactly why this technique is so absolutely crucial. When you run this in your lab and check the statistics I/O messages, you're going to see a night and day difference. Without the hint, the query required 689 logical reads to find the data. By simply adding that option recompile hint, it drops down to just 409 reads. Think about that. That means the query without the hint was doing 68% more work to get the exact same result. You've just saved your server a massive amount of unnecessary effort.
And with that, you now possess all the analytical tools required to absolutely crush this lab. Which brings us to our final step, Section 5, Tear Down and Clean Up.
Because a good DBA always cleans up their workspace, right? Once you've successfully verified all those execution plan improvements, you'll close out your current query windows. Then you're going to navigate back to your File Explorer and delete that C:\lab files folder you cloned earlier from GitHub. Finally, you'll head back over to Object Explorer and SSMS, right-click the AdventureWorks 2017 database, check the box that says Close Existing Connections, and completely delete it. This just ensures the lab environment is perfectly reset for the next run.
All right, we have covered a ton of ground in this briefing. You've learned how to identify those nasty key lookups and destroy them with covering indexes. You know exactly how to track down regression and force optimal plans using the query store. And you understand how to guide a blind optimizer by using variables paired with recompile hints. The tools are right there in your hands, and the environment is waiting for you. You are more than ready to dive in and crush this hands-on lab. But, it really makes you wonder, once you master these skills today, how many hidden performance drains are currently lurking in your own production databases right now? Good luck out there in the lab.
Of lab DP-300 database administrator. We'll go through lab number 10, isolate problems areas in properly performing queries in a SQL database. So still we are progressing with the different performance related issues. So this time we'll go through different SQL and we'll check the query plans and try to make improvements with the database statement. I'll pass this GitHub link so that you can follow when you do into your lab environment. But always make sure that you have downloaded all the required files. And whenever you need a database, you got your right database into server level. Otherwise, you can use a sample data and go through all these labs. So very first thing here, I'm going to log into SQL Server Management Studio. So let me connect there. So when that SQL Server Management Studio open, very first screen you will see that connect to the database or connect to the server. So you need to put the server details, or if there is any specific database, you can go there and select that one. So here I'm going to select with my lab environment. I'm going to select the default setup. So, but in your case, you need to select the server name, select the authentication method that you use. And here I'm going to select that trust server certificate and click connect. And when that populated, very first thing that I'm going to register a database that I will use for on this lab. So here you can select that this databases folder and click the new query. When that you get the page for new query, type the command for registering database. So here I am going to register a database based on the disk backup. That's the backup path. And it will create two file structure, one .mdf for data files and another for log, which is .ldf related to log file. So let me execute this one. So query executed successfully. If I refresh this page, you can see that the database, registered database is here. So now we'll go through few SQLs to generate actual execution plan. So to let me open a new query and type the TSQL or Transact SQL code here. So here I have used that show pan underscore all. So this is mainly to see a text version of query execution plan in the result pane instead of the graphical in a separate pane. So let me execute this one. And you can see that statement text. If you look here, so here you have got the text version of execution plan. So from here, if you see that it's giving a index scan, and if you look there, that the table, you can see that AK employee national on that, and it also shows that the execution plan needed a convert implicit options available. So this query optimizer was able to locate an appropriate index to fetch the required records. To get the data, it actually get that information. But now what we will do next task, we will resolve a suboptimal query plan. So for that, let me open a new query tab. And then you can see that here there is options like include actual execution plan. Select that one. You can also use CTRL+M to get that window. Now type a command to execute. So now here you see that we are searching a query based on we are in where condition we are giving modified date, and we also give a product ID. So let me execute that. And if we go to execution plan, we can see that there is a index scan. Also there is a key lookup. And if we go to a key lookup section, I cannot just move mouse. It just, you can see that the output list sometimes it does not get properly here. You can see there are like a few columns names there, and we need to make sure that it actually has got right indexes for those. So this property is actually indicating that it is performed for each row, because you can see the top level that key lookup, which actually mentioned that it is performed for each row retrieved by query. Therefore, you can see that the key lookup operations and output list is give that you just put a note that all the columns left to identify that what indexes need to be altered in order to remove the key lookup. We need to examine the index seek above, that you can see those options. So how we can improve that one? To identify the index needs to be altered in order to remove the key lookup. So for that, we need to examine the index seek, and then we will do like the create index all those output list columns. So now open a new tab, and now if we go to that the indexes on that particular query that we are doing, that is on sales and sales order detail tables. So if you go to the tables, and if you go to the table sales order detail, if you go to indexes, this is the index that it is using. And if we see there, let me open in another query window, type this command. So here what we can see that it has got indexes for product ID column. So index name is, this is under, you can see that this is has got product ID column. So now from our output that we see that there are few columns, that output list and index seek. We are going to like create a index or alter a index to add those columns here. So for that, let me open a new window, new query window, and execute this query. So here you can see that we are adding product ID, modified date, that also include this tracking number, order query, unit price. Now here we use drop existing is on. So what it will does, like as this index is already there, so that yeah, when you're using this one, it will do, instead of like when it create the index, it will also drop that one, like the existing one, and create a new one. So let me execute that one now. So index is created. Now if we go to the SQL we executed before, this one, let me execute that one. And here you can see that we don't see that like the message we got last time. It was better, so I could open another window to compare that one, so that we can compare the uh, logical read also. You will see that logical reads reduce, So this is mainly logical reads is just reading from memory instead of physical reads, which is going to read from the disk. So what happened after creating those indexes? It actually rewrite the execution plan. There is no need to key lookup in this case, like after modifying that one. Let me open a new query, and now we'll see like the store and detect and handle regression. So for that, let me first uh, open that execution plan and type the command. So now if you look here, you will see that there is a compatibility label. So compatibility label is related to some database version wise. Like in this case, this 100 is for SQL Server 2008. So what it actually does, think that you upgrade your database to a later version. But if you use this compatibility label to older version, then it will not allow you to the new versions. It will use like the old server version. So now execute that one. Then open another query window. Let's open two files. So file, open file that you downloaded through that Git repository. This is lab 10. So first one, create random workload generator.sql. So open that one. When I open that one, include actual execution and then execute that. Then open another query window, get another file, execute random workload. Then execute that one. So when these two execute completes, okay, let me see this first one. So this is a random workload. Then this is the second one. So let me execute second time. Then open a new query window. And now what we are going to do, we are going to change the database compatibility mode. That last time we changed that to 100, which was SQL Server 2008. Now we are going to change that to 160, which is SQL Server 2022. So after changing that one, if we go back to execute random workload, so now we are executing this query again. Previously we executed with 2008 version compatibility. This time we are executing with compatibility SQL Server 2022. Execute that one. So after execute, we are going to examine the top resources consuming queries report. So for me, let's go up, refresh the database. Then um, expand that query store and to see which reports are available so that you can get from query store. From here, select that top resource consuming queries report. And when that report open, when you see the report page, from here you can see that the total duration. And like this side, you can see the total duration versus query ID. This side, you can see that plan summary for a particular query. Like here, 9.5, you can see that one, and that down below, you can see the explain plan informations. Now, if I select the top one and select, then you can see that it's giving a information that which query was run, and object ID, object name, execution count or plan count. And here you can see also there is a configure option. So select that configure. And in the configuration options, you can see that there are different options available, like check for top consumers of duration, CPU time, or based on additional filter, you can do that one. So here we are going to do like filter for our lab purpose. We are going to select that minimum number of query plans that we want is 2. And then select OK. And here we can see the duration. So if we select the long duration, you can see this one here, and we can get the SQL information. So this actually shows us that the query and plan summary for the longest duration one. And you can see that this side, this is the plan summary. Now for a like for this same SQL, like we can force a better execution plan. So for that, what we can do, you can see the lowest duration was this one. If I click that, we can see that there are two plan ID actually. And one is 54. We can see that plan 54, and you can see the execution plan down below. And if you see the 64, we can see that like duration wise, it was more duration, it was less duration, and you can see that explain plan. So let me select this 54 one, and then down below you can see that there is a force plan option. So if you'd like to, like this is we are just telling database that okay, next time if you get this SQL, so use this plan, this explain plan. And if you want that one, you can just click on force plan. Then option is coming that do you want this one to use force, then click yes if you want to. So when plan is forced, you can see that that is actually grayed out, and it became like execution type completed, but you can see there is a check mark. uh, Check mark indicate that it is forced. So this is something like there can be a time when query optimizer can make a poor choice, like on which execution plan to use. So by doing this, we are forcing SQL Server to use the plan that after doing some investigation, we think that this, if query optimizer use this plan, it will be performance will be better. Next, we will see query hints to impact the permissions, impact the performance. So for that, let me first clear screen or clear informations. So if you go there, that file section, no, that is under window because we are going to clear screen. So use that window and there is options called close all documents. So click that one and it's just giving a message, do you want to save? I don't want to save, so I just select no. And when I select no, I see that that screen is cleared now, or clean screen. So now let's do a new query. Select that, include that execution plan, and then type the code here. So if we execute this, and you can always see that here, logical reads, physical reads, or how much time it is taking. And this is mainly the output or data from that table. So now go to execution plan. And if you see here, it's showing that there is a index 6, like index 6 operation is there. And you can get all those list, what actually looking for, like additional information, you can get that from there. Now let me open another query window, and we want that explain plan or execution plan open, and execute another SQL. So if you check with this, only difference is here that the salesperson ID. So we are using for different ID. So let me execute that. So normally what we should see that the execution plan is same. But here you see that there was a index 6 for that salesperson ID 288. But for 277, there is no index 6 options available. So there is a difference. And why it is using difference plan? Because that can happen. Like query uses a constant when we are using a where clause. The optimizer sees that this query is unique and generate a different execution plan each time. So what we can do, we can change the query to use a variable and use a query hand so that it can use like same execution plan or best optimal plan every time. So let me for that one a new query window and then type this command. So if you see here what we are doing, this time we are using salesperson ID 288, but before that we are declaring a variable. So we are declaring salesperson as a variable that matches but you need to make sure that the variable matches the data type of the column that we are using. Otherwise we will see the implicit conversion message like that we checked, I think previous performance first one or second one, so that can happen. So make sure that you are doing that one. So now execute the query. Oh, I did not use that execution plan. Let me add that and now execute. And we can see that it is using index scan. And what we know by this, that this query optimizer could not make good optimization because it cannot know the value of the local variables until runtime. So we declared a variables, then we define that one, but when it is running, only then it knows that this is a, numeric or varchar, those data type. It only knows that one. Now let me open another query window and type this TSQL. So here, if you see here with this one, the difference is we have added option recompile. So we are giving a hint uh, to make a better choice for the optimizer. So what will happen? The recompile option causes the query compiler to replace the variable with its value. So now execute this, and that is other thing noted. Okay, let me execute this fast. Let me add that execution plan and execute that one. This is typo. I need to put that down and now execute. So now if I go to execution plan, you can see this is much better because you can see it needs data 130 of 130, 130 of 130, 130 of 130. But if I go to previous one, you can see that 130 data, but it needs more, 224. So 58% it's showing that one. So actually this case it actually better. Another thing you can check that the logical reads 689 previous time. If I go to this time, if we go here, you can see much lower logical reads this time. So almost 68%. So it's getting data from the buffer, only required data it's reading and giving you faster output. So that's it for this lab. If you have any questions, please add that into comment section, and please subscribe to my channel to go through different other labs also. And I also did like overview so that you can go through overview about these topics before going through the lab.